We're going to take a look at phylogenetic trees. So phylogeny is just the evolutionary history of a group of organisms. And phylogeny can be represented by a phylogenetic tree, and these are also called evolutionary trees. Let's just take a look at a phylogenetic tree. So here we've got the root of the phylogenetic tree. So down here would be our last universal common ancestor. So whatever organism gave rise to our phylogenetic tree. And you always start at the bottom here and then you go up. And here would be our branch point or node. This would indicate that there's a common ancestor here where we had a divergence where one branch went out and gave rise to whatever this species is, and then the other group that evolved from this common ancestor kept going, and then here we had another branch point or node, and we have another common ancestor that gave rise to another group over here, and then this other group gave rise to another common ancestor that evolved into these other two groups over here. And we can also have these sister taxon. A taxon is just a group, and we have a common ancestor here that gave rise to two species here that are closely related, but they evolved from a common ancestor. So when you make these phylogenetic trees, we oftentimes will look for things that these species will have in common. And then we'll make these branch points to say whether or not these particular species have something in common or not. So maybe you're comparing a lancelet with a lamprey, and you're looking at something that maybe they have in common or not. And so maybe you're looking at a vertebral column. Well, lancelets do not have a vertebral column, so you would put them on this branch, whereas everything else here does have a vertebral column, so they would be on the yes branch. And then you're going to look at the next thing that you want to compare and say, well, do they have a hinged jaw? And so now you're looking at the lamprey compared to the fish and everything else up here. And the lamprey do not have a hinged jaw, so they would go down on this branch, whereas everything else does have a hinged jaw. And then the next thing we want to look at is, do they have legs or not? Well, fish don't have legs, but everything else does. And then you want to look at, well, do they have an amniotic sac, around their egg or fetus? So frogs do not, but everything else listed above does. And then you want to look, well, do they have hair or not? Well, lizards, being reptiles, do not have hair, but rabbits do. So that's how they make these phylogenetic trees. They just look at, well, what are things do they have in common, or what do they not have in common? And that's how they figure out who goes on what branch. So you kind of figure out with evolution, how things develop and, who's related to who. Okay, and then here's just another phylogenetic tree, just looking at our 3 domains. And then we've also got the kingdoms with our domain Eukarya. And we talked about this before. We had whatever our last universal common ancestor was would be at the root of our tree. And then as we go up, the bacteria evolve first. And then our domain Archaea evolves second. And then this would all be domain Eukarya right here. And then with our kingdoms here in domain Eukarya, you can see that the protists and the plants actually evolved first, and then the animals and the fungi evolved from a common ancestor over here. And what's interesting to think about is that animals, their closest relative would be the fungi. It's been a long time since we shared a common ancestor. It's been about 1 billion years ago that we had a common ancestor between animals and fungi, but we did at some point about 1 billion years ago. But, you know, we went on one path and the fungi went on another path, which is kind of interesting to think about.